Okay, so any homework questions? Anything we can go over with this? We feel okay? Okay, so then um great. Great. Moving on. So what quadrant, if we're looking at 3, -3, what quadrant are we going to be like dealing with? Quadrants, think one, two, three, four, yeah, four. And that, yeah. So down, yeah, positive x, negative y. So if we go one, two, three, one, two, three, so down here. Yep. Okay, so we drew that point. Awesome. And again, that's an x and a y value, and those are going to be used in my trig ratios over there. Okay. So what can we do now that we did that? What are we going to be like piecing together here? Well, we're going to be piecing together like our triangle, and that involves kind of going from our uh, origin, right? Drawing from our origin over here to our point that we drew. And then what is this right? Do I go to make my triangles? How's that look? Yeah, no, it's because I need to go up. It's always going up to the x-axis, and that's how I form my triangle every time. Every time, even if it's like way down here, you still go all the way up to your x-axis. Okay. And now what can I do? Then I have my triangle drawn. So what can I do now? What can I start to like label? My x and y, yeah, my side lengths, yeah. So like 3 units is this side. And you guys remember, like, yes, as a triangle, this is 3 units long, this side too. But it's better to label it as -3, only because, right, that -3 value, like I said, is going to be used in our trig functions over there. Okay. Okay. Now what else? I have my two sides labeled. So what can I do now? Kind of finish the puzzle here. Yeah, 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 nice. So we can go, it would be square root of 18. Yeah, and we would do 3 squared plus -3 squared, right? Kind of our two side lengths in there. So yeah, this is our setup from yesterday, right? Kind of our two side lengths added and squared. But again, we can't really just throw all this in the calculator because if we did that, it would give me a decimal. Okay. And it's standard for trigonometry. We do want to leave things in radical form. Okay. Um, and just be careful too. If you type this in without the -3 in parentheses, it's going to tell you the answer is -9. And we know it's not, right? We know that 3 squared is 9. We also know that -3 squared is 9. So yeah, the answer here would be square root of 18. Okay. Now here's something else too. Like, let me just say this now. I'm not going to be too like the test here is testing you on your trig knowledge. So it's not necessarily like in algebra 2, you actually learned how to like simplify a radical. You might not remember that. Like right now, this radical is almost like this, like 2/4, like something that can be reduced, right? And so we can reduce this. Okay. Does anybody remember that process? It ends up being, I'll give you the answer and then see if it would be reduced to this. Does anybody remember where those numbers come from? It's, again, it's not a big deal if you don't. But you kind of break this up. You think, does 18 have any factors or numbers that multiply to get it that are perfect squares? Okay. So like you could say 18 is the same as 9 times 2. And the square root of 9 would give you a whole number, right? So that would be 3. Do you guys remember doing that at all? I know it's like, especially if because last year or two you've been at, virtual school and things are easily forgotten. But I am going to do this problem with this. But I'm just telling you on a test, if you kept this, you would not lose any points. Okay, but just kind of letting you know. Because again, we're not testing you on your simplifying radicals knowledge. So, but it should not. You would maybe lose a point or a half point if you put it as the decimal. Okay, because that's again trig. It's standard to leave it in radical form. Okay, so then we got all three of my side lengths here. Okay, and again, I didn't label this too. This right here is my reference angle. Okay, so now that I have all three side lengths, what am I doing? What can I do now? Kind of now that we have all that stuff labeled, I can kind of work on kind of finishing what it asks, right? Filling in all the trig functions, and then I'll use those to help me find my angles. Okay. And again, hopefully this isn't something that is too hard for you at this point. Bless you. So -3 over 3 square root of 2. Okay. And again, also with radical form, typically we would, like, if you were doing it completely, like, we would rationalize this denominator too, get that radical out of the denominator. But again, I'm not worried about that. So, but we can reduce this. Okay. So like you see the 3 on top, 3 on the bottom. We can make that -1 over square root of 2. And that's as far as I'm going to have you guys take it. Okay. Just don't worry about rationalizing here. But so that's sine. What would cosine be then? Just +3 over 3 square root of 2. And again, that can also reduce to 1 over square root of 2. Y over x. And you don't even need to look at the triangle for that. Just at your point. So the y value over the x value, -3 over 3. And that would reduce to -1. Okay. All right. Now, something to point out here too. When anybody remember this from yesterday? We're going to pick one of these in particular when we're going to find my reference angle. Okay. We said yeah. You can't use negatives for that. So that means the only one that's positive is cosine. And so we'll write all our other 3 trig functions here. But then, yeah, when we go to find reference angle, it's got to be cosine. Okay. So then just writing in these real quick, cosecant would be square root of 2 over -1, which is just negative square root of 2. Secant is, again, square root of 2 over +1, or just square root of 2. And then cotangent, also just -1. Okay. Cool. Now, what do we do then to find my reference angle from here? Or did anybody find it? Find the value for that? Yeah. 45. Yeah, it ends up being nice and a nice round number. So our reference angle is 45 degrees. Okay. And to do that, we would, again, take our positive trig function. We would, again, do the inverse trig function. So in your calculator, second cosine 1 over square root of 2. Okay. And if you threw second cosine 1 over square root of 2 in your calculator, you would get 45. Okay. And now just as you do more trig problems, you'll get more familiar with this stuff. But something to notice, right? We talked about, there's that problem on that worksheet you guys did the other day where it was like, where would sine equal cosine? Okay. And it actually doesn't here. It's really close, but because it's this negative throws it off. But when you have 2 sides that are the same length in a triangle, that means 2 of the angles also have to be the same. Okay. And the only way that can happen if we have a right triangle is if both of those angles are 45. Okay. So that can just, like, again, I don't expect any of you guys to catch that because we're still just learning it. But yeah, if you have 2 side lengths that are the same, okay, that means there has to be 45-degree angles in there. Okay, so just a little fun fact for you. All right, and then our last thing here, right, we found our reference angle, we found all our trig functions. Now we're finding our regular theta angle. Now, again, the thing with this is, always starting from that positive part of the x-axis, and it's always going in the positive direction. So you might be saying, oh, is my regular theta -45? And you could say it like that, but again, usually we just say our regular theta is just positive direction going from that initial side on the x-axis all the way to our terminal side here, which ends up there. So how could we now that we know the reference angle, though, how could we really easily find that? Yeah, so just subtract, right? Because think about it, like kind of the green circle here plus this last little red part would equal a full rotation of 360, right? So that would end up being 315. Okay, 315-degree angle. Okay, how do we feel, guys? Good. Now, what I want you guys to do on your own, maybe try number 7. I'll walk around. Okay, again, draw your thing. Let's just get this part. What quadrant are we going to be in here? Quadrant 3. Yeah, both numbers negative, so you can kind of draw your thing there, and you see it goes a lot lower on the y-axis there, so you can kind of draw it like that if you want. and I saw this in the other classes too, just make sure when you're drawing your triangle, we'll go up to this point and then I'll start walking around. But yeah, when you're here, right, you go from our origin, I saw this at least 3 or 4 times in the other classes, doing this. Okay, that is not right. It's shorter distance, right, to go from that point to the y-axis, but you can't do that. We're always going up. Okay, we're always going up. Okay, so that's it. There's my reference angle. Okay, and you kind of piece it together from there. Okay, and yeah, guys, for this radical, cannot simplify that, right? 29 is a prime number, doesn't have any perfect square factors. So we'll just leave that as square root 29. So yeah, I think most kids have the trig functions down at this point, so I'll just write those down. Now guys, the challenge with this one too is thinking about, like, when we go to find our reference angle, initially it doesn't look like there's any positive functions, right? Because you see negative, 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 negative. So it's like, what do we end up doing? So it's just looking at the tangents, if you had a hard time with that. A negative over a negative is a positive, right? Just like how a negative times a negative equals a positive. So we can rewrite that. That's the equivalent to just 5 over 2 and 2 over 5. And so that would be considered like the fully simplified fraction version of those. Okay. And so now look, when we write it like that, tangent's positive, so we'll use that, okay, to find our reference angle. So it would be that equals inverse tangent of 5 over 2. Does that make sense? Hopefully, if you didn't get there. And then, yeah, you fill that in. And then what's our reference angle, this angle in our triangle then? I saw kids that got it. Like, yeah, 68.2 degrees. Awesome. Okay, so that's this angle. And again, just know too that we can use that to then find the measure of this angle, right? Has to add up to 90. But then how we're going to calculate our theta angle is going to be different here, okay? Because again, always starting from this initial side. And now, because the one we just did, number 5, we did 360 minus our reference angle. And that worked because it was in the 4th quadrant, right? Now this one, if we did 360 minus 68 point something, we would get like 290 something. And that would be, if we did an actual 290 degree angle, it would be like all the way over here. Okay. And so that's not what we're going to be doing. So how can we mathematically then figure out, like, to go from here to here, right? And it's almost, you see that it's like including just your reference angle there. So what could we do for this one to figure out what our theta angle is? Yeah, so because think about it, a half turn would be 180, but it goes a little bit extra from 180, right? So it would be 180 plus 68.2. Yeah, so that's how we can find theta. So 180 plus that, and that would equal a what? 2, that's not a 2. Yeah, 248.2 degrees. And that looks more accurate, right? And just, again, just for reference, knowing that like 3/4 of a turn is 270, right? So it should be less than 270. So that makes sense. Okay. Cool, guys. So I just got one last thing for you. This will be quick, so you'll definitely have your like 15 minutes at the end here. Okay. This is just something that's going to help you specifically with this last part, kind of with the kind of going from your trig functions to your angles. Okay. And so I'm going to draw this, and I'm going to give you kind of the acronym. Okay. So if we have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. And it's going to go A, S, T, C. This will all make sense. I'll put it all together here. What you can say to yourself to help remember this is all students take calculus. That's the letters are going to stand for something else related to the trig, but yeah, that's kind of I remember in my pre-calc class in high school, I remember my teacher teaching this, and it stuck with me since then. So one of those, and that's what's nice with trig, like SOHCAHTOA, this, like there's lots of little things you can say to yourself to help you remember stuff. Okay. But what is this telling you? Well, this is telling you specifically, like, if your point that you're starting at, if your point is in one of these, whichever quadrant, okay, that's telling you if the point that it's giving you is in that quadrant, it's telling you which trig function would have a positive ratio that you could use to then find the angle. Okay, so what that would mean is if you're in quadrant one, so if your point is in quadrant one, you see A. So A would stand for um, all the functions would be positive. And so that would mean sine, cosine, tangent. Basically, a point in quadrant one is really nice because it's all positive. You could use any of the trig functions to find your reference angle. It's really nice. Okay, so all the functions positive. But any of the other quadrants is when we bring in the negatives, right? And so obviously bringing in negatives mean there's only going to be particular trig functions that are going to be give you a positive ratio to use to find that reference angle. Okay, so in quadrant two, S for sine. Okay, so quadrant two, only sine is positive. Okay, quadrant three, only tangent. And it's redundant, so you know what that stands for. Only tangent's positive, and then quadrant four, only cosine is positive. Okay, so that can be helpful, and the reason it's helpful is because, like, at the start here, like when you guys are listing out all these all the 6 trig functions, you might be thinking like, oh, that's just annoying having to do all 6 of them. But in a way, it's kind of a blessing because you can see right from there then like, oh, these 2 are negative and that's the positive one. So that's the one I'm going to choose to find my reference angle. But in the future, I'm not going to ask you to find all 6 of those. So you're not going to have them all listed there for you. So like obviously you can list all 3 if you want to, the sine, cosine, tangent, and list out those ratios and then pick the positive one from there. But this just saves you some time because you, even right at the beginning of the problem, right when it gives you the point, you know, okay, that's in quadrant 3. But then you also know, like after you draw your triangle, really the only, if it's not going to make you list out all 6, really the only one that you need to find is whatever one corresponds with that quadrant. Okay. Um, so, and that, because that's the one you're going to do the inverse of that, throw it in the calculator, and it'll give you that angle. Okay.